Welcome to Be Together. This class covers use gINT to leverage the value of your legacy subsurface data. My name is Drahan Toljak, and I'm a Senior Advisory Application Engineer at Bentley. So today we are going to cover leverage the value of legacy data. And we want to go from this situation into this kind of situation. Many companies accumulated a huge amount of paper logs, paper reports of any kind over the time as they grow, and they're facing different types of problems: how to archive this data, how to manage it, how to find it, and so forth. So the logical thing would be to migrate all this data to a digital form. Obviously, an enterprise database would be ideal solution. So if you have your data migrated to a database, you can easily search for this kind of data, query it, show it in different kind of reports, show it on the map, and so forth. And of course, it's going to take much less space in your company, and it's going to be much approachable. So how we created legacy data? Well, by logging in the field. In the past, most of the data was collected with a pen and paper. So a field engineer would take a blank form from the office, go in the field and record different things during the subsurface investigation, like a blow counts, soil description, do some sketches, project name, and so forth. These days, however, we want to show data in a digital form. And usually we enter the data manually in the computer, or most recently there is an option to collect the data in a digital form and basically import it in a database once we are in the office. Moreover, some PDAs allow wireless transmission of the data in the office from the field. So, legacy data handling. Legacy data has been underutilized resource for the following reasons. Collecting data in the field is messy. So it's usually like a mud around you. Sometimes it's raining, so we have some drops of water, mud on your paper, and you have to clean it up when you get to the office. It's also difficult to archive and manage paper logs. When you have only a few projects, it's fairly easy, but as your company grows, your archive is growing bigger and bigger, and it's harder and harder to archive it, retrieve it, and reuse it. And very often, interpretation is only a single view, most probably just logs or just lab results, while there is much more value in your data if you save it in a database and create combined reports that you wouldn't usually create, but it's going to give engineers much better insight of data and how to use it. Make better engineering decisions. So what are legacy data formats? They're most probably paper in great deal of cases, or electronic paper. So paper reports are basically pen and paper reports, but electronic paper are reports that are print. Looks much better, but in essence they don't have a greater value than the paper reports. In a sense, they're hard to use and they're dead end. You don't reuse that data easily. And then we have structured formats, like structured files, text files, for example, for penetration tests, and Excel files where people enter their data in consistent manner. Both of these files are much better than paper in terms of managing data, but to get the full advantage of this data, you want to migrate this data in a database. Now, if we have this data in electronic form, such as structured files, then it's very easy to migrate this data in a database. Now, if you have your data in a database, you can reuse the data in many different shapes, forms, views that people wouldn't even imagine in the past. So the logical question about legacy data is, what's in it for me? No value in migrating data to a database just to get a fancy log. I mean, who's got time for this? There is no money in it, right? Well, have you ever needed to create a fence? A fence diagram is a gINT terminology for a subsurface profile. If you need to cut a lot of fences or subsurface profiles with a lot of boreholes, it will most likely take you hours, perhaps days. If on the other hand, you enter your data in gINT, it's gonna take you minutes to create profiles for any number of profiles. Have you ever needed to create maps in real time and show the data on the map by clicking on the borehole? Any data that is applicable for a certain discipline, for environmental engineering, for water resources, for geotechnical engineering, you're just getting relevant data by clicking on the borehole or on the sample location on the map, or show boring log or any kind of report by clicking on the link on the map. So whether you use Bentley Map, Google Earth, ArcGIS, or any other map program. Have you ever needed to create a surface model? Calculate cut and fill, soil replacement volume, to create a bedrock layer, for example, or water surface layer, or fill stratum? Have you ever have a need for a geotechnical analysis to perform retaining wall analysis, slope stability analysis, foundation design, settlement analysis, tunnel design, and you have to retype your data with the soil properties from log into a geotechnical analysis and geotechnical design software? Well, consider migrating your legacy data to a database if you want to reuse your data for future projects easily. Let's say you have a new project in a vicinity of some old project or projects. So you can go back to your map, you can cut profiles easily and see logs easily to do a preliminary design. So if you want to see your legacy projects on the map GIS, if you want to retrieve subsurface data in real time by filters, queries, and so forth, perform analysis in real time, let's say exceedances, lab results, and so forth, evaluate what-if scenarios. If you want to create subsurface profiles quickly, create surface models with little effort, perform 3D visualization, stratigraphy, plume, and so forth, automate and enforce quality assurance and quality control, then you should seriously consider migrating your legacy data to a database. So how can I calculate return of investment? Not only for legacy data, but also for the future data I'm going to be collecting and that will become legacy with time. So here is the example of the timeline for collecting your data. Whether we create paper logs or reports or we store our data in a database, for the field data gathering, it's going to require the same amount of time. Now, it's a common opinion that if you just clean up your paper log, it's going to take you like less time than data entry time when you get to the office and when you want to enter your data collected in a field and type it into a database. So this is a reason why people stay away from databases. Looks to them like there is more time required and spent on data entry. But very often people overlook that this data doesn't end here. Very frequently we need to perform quality analysis and quality control on this data. We need to create subsurface profiles or fences, do any kind of analysis on the data, modeling, or showing the data in GIS. Now, if you're storing your data in a paper, you will need to re-enter all this data in any of these pieces of software that perform any of these tasks, like creating profiles, analysis, modeling, and GIS. On the other hand, if you have your data stored in a database in a structured order and manner, then performing these tasks will be automated and it's going to be quicker. In addition to that, if we collect our data with PDA directly in a digital form and structured form, then it can be imported in a GINT database, so data entry is completely eliminated. So actually, let's take a look quickly what is GINT. If you're not GINT user, GINT is a database manager and reporting engine for subsurface exploration. It is used for data storage, data validation, data querying, and data reporting, and it can be used as a standalone or by other software as a central repository for a subsurface data. So here we can see a snapshot of GINT interface data entry module on one side, and we can see two outputs. One is a borehole log and the other is a fence diagram or subsurface profile. So who uses GINT? Hundreds of consulting firms, large and small. So you can see some of them here listed. This is not an exhaustive list, but it will give you a good idea. We also have a lot of government agencies as clients, among which are 32 US state DOTs, US Army Corps, US Bureau of Reclamation, USDA, US Geological Survey, EPA, Federal Highways Administration, and so on. So why good data or database is necessary? It is going to enable a centralized data management at corporate level. This is most likely be a challenge, but one well worth the effort. With a single database structure, various stakeholders can easily share data, or stakeholders for soil design, for soil data. Pretty much everyone in engineering, like for example, geotechnical engineers for geotechnical design, retaining wall design, slope stability, foundation design, settlement, and so forth. Road design engineers, for obvious reason. Building industry for foundation design. Bridge design engineers for foundation again, and so forth. So GINT provides tools that can automate many processes in migrating your data, managing data, reporting data, and sharing data. Here is a slide describing idea of collecting all your data in the company and centralizing it in one location in database. Very often companies have their data dispersed around the network, on the shelves, in their drawers, and so forth. That may be a lab data, electronic field data, for example, cone penetration test, data collected with a pen and paper, or saved in some documents such as Excel files, Microsoft document files, text files, or even directly collected in a digital form with a PDA. Very often, again, this is saved in different files, different locations, different formats. Instead, we are proposing to consolidate all your data in a central location so everybody can reach it at any time and they know where to go for data. Since October 2009, that's some 6-7 months ago, GINT has become part of Bentley. So GINT is powered by Bentley, but can be used as a central repository of a subsurface data by a range of engineering software. Here is the snapshot of just few of them. First, Find Software is a company that makes so-called Geo5 suite, which is geotechnical analysis and design software for designing slope stability, foundation design, sheet pile design, settlement, finite element method analysis in geotechnical engineering, and so forth. Bentley is an exclusive representative for Geo5 suite for North America, and Geo5 suite and GINT communicate easily, so all the soil data required for geotechnical analysis can be easily transferred from gINT into a GeoFive suite for the further analysis and design. Next, we can see ESRI, very important player in GIS market. There is a gINT for ArcGIS, a tool that one can use inside of ArcMap to directly connect to a gINT database and retrieve all relevant data to show locations of boreholes, of soil samples taken in the field, of pictures taken in the field, and so forth. And then we have a Google Earth, becoming more and more popular tool. There is a gINT for Google Earth that comes with gINT. So basically it enables you to harvest your data from gINT database and display it on the map, display links to borehole logs and any kind of reports as well. Then Rockware, that makes rockwork software, so that is used for 3D modeling of stratigraphy, of plume analysis, and so forth. Earthsoft, that makes Aquis. Aquis is a popular tool for environmental scientists. It's also a database tool, and these days many environmental companies are stepping into a geotechnical field, and geotechnical companies are stepping into environmental field. So there is a lot of data saved in gINT and a lot of data saved in Aquis, and people want to exchange this data, so gINT has tools and capabilities to automate this data exchange. Then Surfer, used for creating surfaces, and Autodesk has some functionality that can be replicated what Bentley products do, like Inroads, Geopack, MX Roads, Project Navigator, and so forth. So for further reference, I would encourage you to go to our gintsoftware.com support page. There is a document called 101 Things You Can Do with gINT. So it's going to give you like a great idea of how you can further explore and manage and utilize your legacy data, how you can handle and manage gINT and gINT database. And there is a lot of free resources like free logs, free reports to download. And as we are getting closer integrated with Bentley, all these materials and the knowledge is going to eventually be migrated to a Bentley servers. So I encourage you to take a look at Bentley Learn Training subscription. You're going to have a lot of training materials over there available. It's really extremely valuable source of knowledge. And now we are going to demonstrate some of the approaches how to start with a lot of legacy data that you would like to digitize and then eventually display in different kind of environments. So let's consider a few options how we can handle our legacy data. As mentioned earlier, a great deal of subsurface investigations were recorded with a pen and paper. Here is one example of log of boring. So we can see here project data, sample description, some numbers related in this case for standard penetration test, some sketches, some notes of different kind. So a company can accumulate a great number of these log of borings over time, most probably hundreds of them. Obviously, it would be extremely time consuming to retype all this data into a database. But at the same time, it would be very useful to have this data in a database, and so it can be shown on the map. Let's consider how we can start lightly and then expand if we need some more data entered in a database in greater detail. So I'm going to open a geotechnical database that is very simplistic to start with. It's going to be a legacy project. Notice that this database has only two tables. One is called project, and here we can enter basic information about the project itself, who the client was, name of the project, number of the project, where it happened, and so forth. Now there is another table, again with very few fields, and basically it gives us a borehole name, it gives us total depth, and some coordinates. Doesn't have to be very precise, especially for the legacy data, but close enough. Surface elevation, this can be most probably read from the log itself. Maybe date when it started, maybe notes. And one field that is very important here, this is any type field, and here is where we can save pointers to scanned files, such as for example logs. So basically this is LBO4, for example, log saved here. I'm going to launch it, and this is going to give me log of boring. This is the simplest approach to start with archiving your borehole logs or soil exploration reports into a database. Obviously, this is going to take just a little time because you have to create like two tables, and just a few fields, and these days you can scan your logs in great numbers very quickly and then save it here. It is not uncommon that companies hire interns to do that over the summer. So once you enter majority of your project in this simplistic manner, dozens of them, maybe hundreds of them, you can expand on the idea for more significant projects. So instead of entering only basic information, you can enter like all information and have it in a very structured manner so we can harvest this data and show details on the map. I'm going to open now a database that displays such concept. So you can notice that this database has much greater number of tables, and each table has a great number of fields. So in this case, borehole table, besides having borehole ID, total depth, some coordinates and elevation, have all additional information that an engineer would need to find out about. Then we have some lithology descriptions, also entered from the log, relevant sample data, like blow counts, maybe some RQDs, rock quality designation, recovery length, types of sampling, very important data. If there are any water levels information, you can enter that in a separate table. Any relevant environmental data, you can expand on that. Have multiple tables to accept different kind of data. If there was any well data associated with a borehole, and then of course if there are any generic remarks. You can also show your boreholes on a sitemap in gINT. And notice that there is a lab testing module, CPT data if there is any, and so on and so on. So once you migrate your soil data, whether geotechnical or environmental, into a database, you can take much greater advantage of it. You can show it on a map, you can show it in different kind of applications, you can harvest your data, you can filter, query, click on the borehole location on the map to display borehole log or other reports and so forth. We're going to demo some of it. Before we start demo, I want to emphasize that there are two flavors of gINT. One is gINT Professional, which is Microsoft Access based, where you save one project into one database, and the other one is gINT Professional Plus, where you can actually save multiple projects into one database. So imagine you have a central repository for your geotechnical environmental data for the company, and then you can save all your projects, all your boreholes in that one location. So first, we are going to demonstrate how to upsize your project. Upsizing in gINT terminology means how to get your data from Microsoft Access database into a central SQL Server database. So here is our database, gINT database, a legacy project, and under Enterprise menu, we can use upsize project to enterprise or upsize multiple projects to enterprise. So first we have to select the server and instance, where to upsize to, and we can create a new SQL Server database or select the existing one. We can use authentication, either Windows authentication, or we can enter user and name and a password separately, and then we will select multiple projects to upsize to a gINT Professional Plus. So okay, this time if the new database is created, then the structure of the database will be replicated first, and then data will be populated from Microsoft Access database to a SQL Server database. Note that this is not required step, this is just an optional step that gives you even more power. So one database, multiple projects, instead of multiple projects saved in multiple databases. So project upsized, we can see source, projects, and the destination database. At this point I'm going to open Enterprise database and see our data that has been upsized. Here, notice that there are 3 projects currently in this database. Their numbers we can see here, locations, and all relevant data. Notice boreholes that we imported, and these are projects, so we can select different projects to display different boreholes related to these projects. We can also show these boreholes on a sitemap inside of a gINT. If you're using gINT as a standalone product, here's what you can do. Import a sitemap, and then if you have coordinates entered for your boreholes, it is going to show these boreholes on the sitemap. So here we are demonstrating different boreholes related to different projects. Great. Once we have our data upsized or saved in a database, now we can do many interesting things with it. So in this case, we are going to show how we can connect actually our gINT database to ArcGIS and demonstrate what we can do with this data now. So connecting to ArcGIS, there is a GINT toolbar for ArcGIS that comes with GINT Professional Plus, and we are going to demonstrate how it works. So first we are going to open ArcMap and then add data. This is going to be a site map. In this case it's going to be a DXF format, and so we are going to attach that to our ArcMap project. Okay, this one is not georeferenced for that purpose, but it's still going to function because borehole locations are properly entered. Just the ArcGIS functionality. Since this is DXF format and this is a vector file, I want to disable selecting vector geometry here. Also, I'm going to do some visual aids so we can spot our borehole locations easier once we import them. Okay, so we have our sitemap ready. Now we are going to retrieve GINT toolbar for ArcGIS. So here it is. It has only a few available tools right now, but it's going to give you a great power to retrieve your data from a GINT database. So first we are going to connect our GINT database with this map. So again, like first we select server instance. Ideally in your company you're going to have only one soil database as a central repository. It can be secured by password or via Windows authentication. So you select the appropriate database, select the appropriate provider, and then click OK. At this moment, this is going to bring your borehole locations directly into this map. So basically right now we have a live connection between GIS environment and GINT database. I'm just going to change few of the label properties so we can notice our borehole locations much easier. So basically right now we imported like 3 projects. Here is one project, it's Legacy project 025 as we called it, and with 2 boreholes. This is just a simple example to demonstrate the concept. And then we have current project 255 and current project 125. So basically all together we imported like 3 projects into a single map. So basically if you are a company work statewide, you can have a state map imported and show all your boreholes your company ever performed, and retrieve data in much easier way and quicker. Let's explore other features that are available in GINT toolbar. I'm going to launch ArcGIS again. I've saved that project earlier that I created. It's going to retrieve all my boreholes. And when I start using GINT toolbar again, first thing that is going to happen is reconnecting this map with a GINT. Once we save our ArcGIS project and then reopen it again, we have to re-establish that GINT connection. And that's going to happen automatically when you click on a GINT toolbar or any command. So this one right now is demonstrating like what options are available on the right-click menu when we select a borehole. So any command that we select from that toolbar is basically calling information from GINT or related to GINT database. So obviously you can see here we can zoom to a selection. In this case we selected 2 boreholes for 1 project, and then we can zoom to that project or to selection. Then we can get GINT project details, here it is. You can see client name, project. So now we are harvesting this data from the database, but inside of GIS environment, where we see a map where all these data makes much more sense than just going through the paper and then comparing to the maps and then going back and forth. Here, one screen, one location, or all this information available to us. It's much more advanced approach and turning data basically into information. Right now, basically, we want to preview our borehole log straight from the map. And all we have to do is right-click on the borehole location in ArcGIS and say View a borehole. That is going to launch gINT in the background, and gINT will generate a borehole log, as we can see. Okay. We can also clear selection if we have multiple boreholes selected. And let's go back to our legacy project. So remember, legacy project was very simplistic one. So now we are going to see like associated file for it, because gINT cannot generate borehole log for that because it's scanned in there. Data was not entered, but just a scanned file. Now we can see that basically from here. And click on a view file button, and here it is. So I hope this gives you an idea that you can scan your boreholes, make simplistic gINT projects, and display them on the map, either in ArcGIS or Google Earth environment, Bentley map, and so forth. You can also retrieve some queries saved in gINT, like give me a total length of drilling, or rock elevation. If you want to maybe create a rock surface, it's going to give you like XYZ or northeast and elevation for the values related to rock for each borehole. So field samples and so forth. So here we are retrieving all samples in the field for selected boreholes. That can be per project, per borehole, multiple projects, and we can export that to an Excel. I'm going to clear selection now. Notice that we can select a whole project for the selected boreholes. So we select one borehole and say like, okay, select me all the boreholes related to that project. And in addition to that, we not only can create boreholes for it or generate boreholes, we can create a whole bunch of other reports like graphs, histograms, graphic tables, anything that is saved in map. We can also call a sitemap that we have previously seen in gINT and basically preview that as well. So you see, like, seeing the same information in different forms, shapes, in different applications, so you can make better engineering judgment. I'm going to clear selection now. Okay, let's explore a fence-based line tool in a gINT toolbar for ArcGIS. So if you have gone a little bit further than just a basic import of data in gINT and scanning your files, let's say if you entered more data in gINT database as the second example that we shown before. So you pretty much enter the data from the log inside of a gINT. everything like soil description, sample data, sample types, borehole information, and so forth. Now we can actually take greater advantage of the whole thing. Right now, what are we going to do? We are going to cut sections, subsurface profiles for multiple projects. In this very case, right now, we can see current project 125 and current project 255. So we are now making a subsurface profiles across the multiple projects for the specific baseline. If you're a road design engineer, then baseline is something like alignment, let's say. And we select appropriate project, and then we create a subsurface profile, or fence as we call it in GINT. Here it is. So let me zoom in, and if you remember, BH07 and BH02 belong to one project, and the rest of the boreholes belong to other projects. So there you go. Last thing we want to show today is displaying GINT information in Google Earth. There is entire GINT for Google Earth seminar on a Bentley web page dedicated for e-seminars. So if you want to get more details, please go to the web page and run the recording. Here we are going to show only the concepts. So we are going to go to the GINT, and we are going to run a command called view features in Google Earth. This is going to create KML file, which is read by Google Earth and other applications. So first we name KML file. It's going to create the file and launch Google Earth if it's installed on your machine. All your boreholes will be displayed on a map, and by clicking on any of the borehole, you can display required information on a map. So in this case, we are displaying surface elevation, hole inclination, hole depth, water depth, bedrock depth, and so forth. Notice that there is a link associated with this bubble, and basically this links to a report of any kind. That can be a borehole log, that can be a lab report, or any other kind of report. In this very case, we have a borehole log, and if you remember our legacy data, that can be also a scanned log of boring, saved in a database and shown here. In addition to that, we can show images. That can be a field equipment image, or core samples image, or any kind of field sample shown here, test bit, and so forth. We can have multiple images associated with the project. And imagine that you save all your projects in one map, and you can retrieve it easily. You can see the locations. You can even include your logo on the map. This would conclude our class, Use GINT to leverage the value of your legacy subsurface data. I hope you have a clearer idea how you can reuse your data, how can you migrate your data from a paper or from multiple formats into a single database, and how to reuse it in the future, how you can start with a simple database, show your information on the maps, and then expand per need be. It should also give you an idea how you should handle your data in the future. Once again, my name is Strahan Toljak, and I'm a Senior Advisory Application Engineer. Thanks for attending this class, and thanks for attending Be Together. I hope I see you next year.